We've talked about using sampling as a way to gain information about a larger population. The basic sampling strategy is a simple random sample in which every group of a certain size, the sample size, has the same chance of being included as the sample. This is done generally by just guaranteeing that every individual in the population has the same chance of being chosen. However, there are some circumstances in which simple random sampling may not be the best choice. So we're going to go through a couple of characteristics of the population that may lead us to another different sampling strategy. If you have a population which is diverse, in which you can identify groups that might have a different opinion, that might have a different response to a certain circumstance, where the variable of interest you think is related to the membership in the subgroups that they are included in, then by random selection you may get a sample that may not be entirely representative of the population. In this simple example, we're choosing 6 from a population. In the previous case, if they're all, as far as we can tell, about the same, then any 6 are as good as the other. If we know, however, that some of the members of the population have certain characteristics that might lead to different measurements of the response variable, then by random selection we might, as is illustrated here, get 4 stars and 2 smiley faces and no flowers. So if the flowers were different, then they're underrepresented and the stars are overrepresented. This isn't a bias of any sort really, it just means that when we do random selection, we're going to get more of some, fewer of another in almost every random selection. In this case, then, an approach might be to stratify the population first. So by stratifying, you're grouping them together into those homogeneous groups which share those characteristics. This is not a random process. You're identifying them specifically by those characteristics. Then, once they've been stratified, you can make sampling from each of the strata. And if you do random selection from each stratum, then you make sure that the sample that results, at least as far as this variable that you've identified, in this case the flowers, stars, and smiley faces, are equally represented in the population. This generally leads to less variability in the sample results that you would get if you repeated the sample over and over. We'll look at some examples of stratified sampling in class to reinforce this idea that it does get you less variability in sample to sample. A third case in which you might adopt a sampling strategy, which is different than just a simple random sample, is if your population comes in groups that are natural clusters together. You can think of this like a school, for example, where if you wanted to have a sample from the student population, there's about 740 students at PCDS. If you're going to sample them randomly, you'd put the 740 names in a list, rand_int 1,740, and you could find those students. You'd have to go hunt them down, however, throughout the campus. They'd be all over the place. Students do come naturally grouped in classrooms, so if you wanted to do a survey, for example, you could go to a classroom and pick several classrooms at random and then sample the students in each of those classrooms. That might be very much easier than would be the case if you were just going to sample randomly in a simple random sample. So in cluster random sampling, you randomly select the clusters, the groups, in this case the classrooms, and sample from those. So here are the 3 pictures which indicate, because of the structure and nature of the population, why you might choose different sampling strategies. If it's easy to pick random members from a population and you can't see any distinguishing characteristics, then the first case is what you've got and a simple random sample makes sense. The second case, when you know that there are characteristics that you can easily identify and group people into these different groups, then you might adopt stratified random sampling. And the third case is helpful if there's some natural clusters or groupings of the population that you can use to simplify the process of making the sampling. So let's look at this process of making a choice about a sampling strategy in a little bit more detail. Here's a document that you'll get in class tomorrow, and we'll use as a guide to planning the sampling surveys that we do. So here's the, at the beginning part of this, you can see there's a set of questions which are going to guide the decisions that you make. First, you need to identify exactly what population you're trying to describe. Are you talking about PCDS students? Are you talking about all students in Phoenix, in the Phoenix metropolitan area? Are you talking about all students in the United States? If you say you want to understand something about students, you need to say which students you're really talking about. Secondly, you need to identify what characteristic of the population that it is that you're trying to measure. So for example, if you wanted to know the average height, that's one thing. If you wanted to know the average SAT score of seniors, that's a different matter. And thirdly, so given the population and the characteristic that you're trying to measure, what's the right sampling method for you to choose? In deciding which method is best, there's a couple of questions that we're going to explore. And the first one is there an easy way to get a list of all the members of this population of interest? If the answer is yes to that question, then you have certain options. If it's no, then your options are more limited. Let's assume for now the answer is yes. Yes, we can get a list of all the members of the population of interest. Then what? Well then, what we're going to be interested in is, are there easily identifiable characteristics among these individuals that we think are related to this response that we're trying to measure? If the answer to that question is yes, then what we're talking about is an opportunity to use stratified random sampling. So those identifiable characteristics, those become the strata. In each stratum, the people who make that up are alike in terms of this characteristic, and then random selection happens from those. On the other hand, if you don't see any easily identifiable categories, then the next question to ask is, would it be easy to gather data from a randomly chosen set of people from the population? In other words, if I pick person number 347, is it easy to find and interview or find and measure person number 347? If the answer to that question is yes, then a simple random sample is probably the way to go. You've got a list. It's easy to get to individual members of the list that you happen to pick, and you're ready to do a simple random sample. On the other hand, if you pick a random member from the population and it's really hard to find them and track them down, then the question is, are there groups that would make it easier for you to complete the sampling process? So even if you have a list, if it's really hard to get to individual members, then you might look for groups, clusters, which make it much easier to get the information that you want from the people who are going to be included in the sample. Cluster sampling is going to work best if the clusters, these groups, are reasonably representative of the population of interest. And if that's true, then a cluster sample may be a very good choice for you. If the answer to that question is no, there are no natural groups, and remember how we got there this first time. We said, is there an easy way to get a list? Yep, we've got a list. Can we identify any variable characteristics? Not really. Would it be easy to gather data from a randomly chosen population? No. And are there groups? No, that we can easily see might be representative. Well, then we've got a tough case. This is the difficult situation in which many polling organizations find themselves, where they have to adopt some aggressive strategies to try to get a sample. You can also get to this point if, when the first question was asked, is there an easy way to get a list? If there is no way to get a list, then you really can't do a stratified random sample. Without a list, you can't put them in strata very effectively, nor can you make a simple random sample. So you maybe then, in this circumstance, by saying, no, we don't really have a list, but we do see these groups. And if you do see groups like that, then you can consider a cluster sample. If not, then again, you're in the difficult circumstance where you've got to think hard about how you might be able to get a sample that you hope is reasonably representative of the population. In all of this sampling, our goal is to get a representative sample from which we can make some conclusions about the population based on the information that we have in the sample. That's the basis of a lot of statistics, and there's a lot of what you'll read in newspapers and magazines that are presentations of data based on simple random samples, stratified samples, cluster samples, or other kinds of sampling methods.